All right, let's see if we can make sense out of this problem. R of t is the amount of sand on a beach in a small ocean park. The tide is removing sand, so R is standing for the removal as time passes, and it's given by this. Now, just for your information, the period of a sine function is 2 pi divided by the period is the number that's times the variable. So that is 4 pi over 25. Well, to make that 2 pi, we have to divide the numerator by 2. And so it's 25 divided by 2, which is 12.5. And this is the time here in this problem is measured in hours. So it's 12.5 hours as the period. Well, it turns out because of the way the moon and the sun are orbiting each other, a period of 12 and a half hours is about right for changing tides. A very rough approximation, but okay for this case. So somehow this is modeled by sine. It's removing for 12 and a half hours, moving and then adding, and then removing and then adding, because it does 2 high tides or 2 low tides in 24 or 25 hours. So every 12 and a half hours, it's gone through this removal and addition. Let's take a look at what that looks like. So my calculator, I've typed that in equation 1. So I'm going to go back here and turn this equation off by pressing enter and zoom. Let's see, mode is in radians. Zoom trig. So I need to see a little higher. So I'm going to make my y max maybe 6. And we're doing this between 0 and 6. 1, 2, 3, 4, 5. So 6 is off. So this curve is saying it's removing sand at a rate of 2 cubic yards per hour. Cubic yards of sand per hour. Starts off taking 2 cubic yards per hour, and then it goes to 3 and 4 and 5 and 6 and 7, and then comes back down. So it's removing cubic yards, and finally it starts adding back. So since it's removed, this is a graph of how fast it's removing. This is when it was adding back, and this is removing, and this is adding back, and then removing. That's what they're going on here. But they say this is only good up to about 6. I should probably move my window up so that, x is 8. I need to make my step not in terms of pi by 1. So here we go. There's 1 hour, 2 hour, 3, 4, 5, 6 hours. Okay? And I should see a little bit higher. Let's make it 8. Okay? All right, it's 2 plus or minus 5, so it goes from minus 3 to plus 7. That's how the sign works, okay? Now, the other function is showing how much sand is being added by a pumping station. So they're trying to keep this beach nice for the park. So they've got a pump running. So let's turn that equation on and turn the other one off. And now let's graph. So at 0 hours, they're not adding, but then 0 cubic yards per hour. And then it goes quickly up to 1, 2, 3. And after 1 hour, it's up here at almost 4 cubic yards per hour, and then gets closer and closer and closer to 5 cubic yards per hour. Now, this is how much is the rate at which they're adding sand, cubic yards per hour. Now, if I want to know how many cubic yards are being removed, I would look at the area under the curve. So the yards removed as a function of time would be integral from 0 to t, the area under the curve from 0, since we're doing this from 0 to 6, of r of t, but I got to use something else. Well, if I'm using t here, then I need to change this. So I'm going to call that x. The amount removed in x hours is the area under the r curve dt. And the amount added, if I put x, is going to be the area under the curve from 0 to x of s of t dt. Okay? So let's see what have we done here. What's the definite integral that measures how much sand the tide will remove between 0 and 6? Well, the definite integral that we'd remove, we'd put 0 and 6, and that would be just that, the antiderivative of this evaluated from 0 to 6. Okay? Write an expression y of t, the total number of cubic yards on the sand at the beach at any time. Well, they say it starts with 2,500, so it's going to have 2,500 cubic yards. And then there's going to be sand being removed, so it's going to be minus the integral from 0 to whatever time they stop at of r of t dt. But then there's sand being added, so plus the integral from 0 to x of s of t dt. That would be the total amount of sand on the beach. Now, these two could be combined. It could be written as 2,500 plus the integral from 0 to x of the sand being added, s sub t, minus r of t, the amount of sand being removed, dt. Could be written that way. And then it says, at what instantaneous rate is the total number of cubic yards of sand on the beach at time 4 changing? So this is the rate of change and rate of change. So you put 4 into this and 4 into this one and subtract this one from this one, and you'll find how much is changing. The instantaneous rate at which it's changing. And approximately what time is the amount of sand at the on the beach the least? Well, we can go back to here and turn the other one on, and we can get it from these graphs. It says at time 0, there's no sand being added, and there's sand being taken away. After 1 hour, there's sand being taken away and sand being added, but more being taken away than added. At 2, more being taken away than added. At 3, and so on. It's here where now the sand being added is more than being taken away. And so this is the lowest. It's taking more away than being added all the way to here, and then it's going to start building back up because there's more added than taken away. So that's the point we want to know about. And that's second, calculate the intersection of the blue graph and the red graph. So I'm pressing enter to select those two. And now it's I need to find out at what hour that is. And it says it's 5.117 hours and that has a rate of the amount being sand being added and subtracted are equal, and are equal to 4.69 cubic yards per hour being added and taken away at that moment. Shortly after, there's less being taken away and more being added. Okay? So that's how they got their answers there. But I want to show you, let's just look at how much sand is being added or subtracted. I'm going to skip the 2500 and I want to look at just this. And I want to show you how you can do it on a calculator. Let's see if it'll work this way. So I'm going to go over here and I'm going to turn that one off, turn that one off, and I want to do just how much sand is going to be added. So I'm going to go to Math, go to Functions Integral, and I'm going to go from 0 to x of, I want to do S sub t, the amount added, which is y2. So I'm going to go second vars, and, just vars, y variables, function, y2, and I have to say as a function of t, alpha t, minus y1 of t. So I'm going to go vars, y vars, function y1 of parenthesis t, and the variable in the integral is t. Now let's see if this will do it. I'm going to press graph. And it'll take it a while because that's a complex thing to calculate. Let's see if it'll even do it. Come on. It's taking its time. Let's see. Up here it says it's still working, still trying to do it. There's a lot of calculations it has to do to make this graph. What I should have done is started it closer to 0 to 6. It might have gone faster. I'm going to press on to stop it, and I'm going to do that by saying go from 0 to 6. And now I'm going to push graph. And there it's showing losing sand. Now, if I had included the 2500, this would have been up here at 2500, and this would be how much it would be coming down. It'd be getting less than 2500. It's slowly working its way across. Pretty darn slow. Remember how the two graphs were the red one went up pretty fast and the blue one started here and got really close, so there wasn't much changing. So there wasn't a lot of change in here. These were close, the red and the black. The blue was higher than the red, so there was more losing. So it's been losing, but they were pretty close. Then the blue got pretty high as this one went like this, and so it should lose quite a bit for a while. That's what we're seeing now, losing more. And then eventually at that 5 out here, it should catch up and then start gaining. So yeah, I wish I could speed this up some way for you. But that's what's going on there. I'm going to do this again on Desmos. Make sure, well, you can do exactly the same stuff. If you type in the functions, if you type in r of t equals this, type it exactly like that. Type s of t exactly like that. Then you could type this whole thing and it'll happen at 2500 way high off the screen. Or you can just type this in to see how the sand is, now it's taking more off than it's adding, so it's going down pretty fast, and then it'll start recovering and come back to adding sand, start coming up. And at 5.1 it's going to be the lowest, so I'm not going to see it here. It's going to be off the screen, so no sense in keep going, but it's going to come down and then it'll start adding after that time of 5.1 that we saw the graphs intersect. That's a better explanation of what's going on in 5 than in my other video. So hopefully that makes sense. You get to see how to do it here, and you can do the same thing on Desmos.